So in the last session, we have discussed about the name node architecture and how the name node is started. Initially, the checkpoint and journal will be empty for the new cluster. The empty checkpoint will be loaded and empty journal will be loaded and replayed, and empty checkpoint, empty image will be loaded as the checkpoint, updated as a checkpoint, and then start services. Whenever you give some transactions, whenever you perform some transactions, they will be recorded in the journal and they will be updated in the image. And then whenever you restart the machine, whenever you restart the name node, at that time the image will be reloaded again, meaning that the checkpoint will be loaded, empty checkpoint, and the journal is having the new transactions. They will be loaded, they will be replayed, and image will be up to date, and that updated image will be replacing the checkpoint, and so the checkpoint is up to date, and then journal will be empty, and then the it starts the services. This will be a cycle. So this is the name node. Now let us discuss about data node, how it is maintaining. Please remember that we didn't discuss about the list of blocks, where it is getting loaded, the list of blocks. That will be in the next slide. So see here, let us discuss about the data nodes. Data node is also having the file system as well as the RAM. Now in this, the data node is having, we are considering only the local file system in the data node. The basic purpose of the data node is to handle the blocks, to hold the blocks. So the block will be stored in the secondary memory of the data node. Now the block consists of, what is the structure of the block? The block consists of the file 1, it is the actual data, and the second file, it is having the metadata like the checksum. I think you may remember that in the computer networks, in the data link layer, there is a checksum calculation to verify whether the given data is transferred successfully or not. So that is the checksum. The checksum will be maintained, and then generation stamp when this block was created. And also this is the structure of the block, and these blocks, the data node is responsible to store the number of blocks. Not only a single block, number of blocks can be maintained by the data node. Now how the data node will be started? Again, for starting of the data node there are several steps. First step is, whenever the data node is started, then immediately it will communicate with the name node by using the handshake protocol. So just say that, hi, I am here, like that, and then it will verify whether it is connected to the correct name node or not, so that it will verify the namespace ID, whether it is connected to the correct name node or not, because it is in the internet. Within the network there may be number of name nodes, whether it is connected to the correct name node or not, it has to verify. Next step is register, meaning that whenever the data node is connected to the name node, it has to get registered that yes, I am available. And next step is storage ID, meaning whenever you connect the data node to the name node first time, then the name node provides the storage ID only at the first step only, first time only. Next time onwards, the same storage ID will be maintained for the data node. So every data node will get the storage ID when it is connected first time. And then send the block report. Next step is send the block report. Okay, now the data node will maintain the block report. It will maintain the block report that consists of all the blocks information like block ID, generation stamp, length of the replica. All these will be maintained. It is like a table that will be sent to the name node. Now, as you remember, list of blocks is there in the namespace. That list of blocks will be generated and constructed by using these block reports from all the data nodes only. And then this is about the starting of the data node. Now once the data node is connected to the name node, started, then it has to communicate with the name node. How it can communicate with the name node? That is by using the heartbeat. So for every 3 seconds, the data node will send the heartbeat to the name node. Whenever it will wait for 10 minutes for heartbeat from each and every data node. After 10 minutes also, if it is not getting the heartbeat from any data node or any of the data node, that data node will be considered as dead. So that, see here, the heartbeat will be continuous process for every 3 seconds. Along with this heartbeat, it will send some information also. Along with the heartbeat, it will send the information that total storage capacity, fraction of storage in use, and number of data transfers in progress. So why it is? Because there may be the increase of the storage. You may plug in some more storage dynamically. At that time, there is a chance of increasing the storage capacity. So total storage capacity, what is the total storage capacity? Fraction of storage in use, and then number of data transfers in progress at the current time. How many transactions are in progress for this data node? That will be also given. And how the name node will communicate with data node? The data node is communicating with the name node by using heartbeat. What about the name node communication with data node? That is to reply from the name node to the data node, reply to the heartbeat. For every heartbeat, the name node will reply along with some instructions. Some of the instructions are like this: replicate the blocks to another nodes, remove the local block replica, re-register or shut down the node, send an immediate block report. Now, replicate blocks to other nodes. When it will be happen? That is, as we discussed, the blocks will be stored number of times. Block 1 will be stored number of times. That number is called the replication factor. Let us say, for example, replication factor is 3, meaning that each block will be stored 3 times. Let us say, for example, the block 1 will be stored in data node 1, 2, 3. Now at this time, 3 nodes are maintaining the block 1. Now whenever one node is down, then the replication factor becomes 2. Now what should we do? We have to rectify that. For that, the name node will send the instruction that replicate the blocks to other nodes, to the remaining 2 nodes, one of the remaining 2 nodes, that replicate the blocks to other nodes, so that there are 2 replicas available, one is down and another block will be created, another replica will be created. At this moment, again, this is the instruction, first instruction. Second instruction, whenever the dead node is again alive, then 4 replicas are available. Actually 3 replicas, replication factor is 3, but 4 replicas are available. Now we have to remove 1 replica. Which replica has to be removed? That is depending upon the situation. So how it can instruct? That is, see here, the remove local block replicas by the name node to the data node, that instruction will be given. And then re-register or shut down. Re-register or shut down, meaning that you can shut down the machine. Like that, you can send the instruction, send the immediate block report. Because of some situations, the list of blocks may be missed. So at that time, it may ask for the immediate block report, so that it has to send. So this is about the data node concept. We can continue in the next session.